Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be covering 6.1, which is geometric sequences. Unit 6 is covering exponential functions. This is technically a review section. We've covered this before in Integrated Math 1, talked about it a little bit in Integrated Math 2. You'll find that some sections, if you're following along with the Integrated Math textbook, are literally copied and pasted into different years. Some of these sections I've omitted. We won't cover them multiple times, but if it's important enough or if it comes up on the CAS, typically we'll cover it more than once, so that's what Unit 6 is going to be. Hopefully it's review, hopefully it sounds familiar. 6.1 is starting with geometric sequences. So in 6.1, the first thing you're asked to do is identify what is a geometric sequence, and that's in contrast to an arithmetic sequence. So an arithmetic sequence, what we're not looking for, is a pattern of repeated addition or subtraction. We talk about arithmetic sequences in Integrated Math 1 when we're looking at linear functions, because if we look at a linear function, say y equals mx plus b in slope-intercept form, that rate of change, the m, causes the value of x to increase by the same amount every time, specifically by a pattern of either repeated addition if it's positive or subtraction if it's negative. When we're looking at sequences specifically, if I have something like 2, 4, 6, 8, 10, you'll be given a sequence in this assignment and asked to identify is it arithmetic or geometric or neither. Okay? If you can find a pattern of repeated addition or subtraction, that is an arithmetic sequence. So here, looking at the pattern between the numbers, I'm adding 2 each time. So because the pattern is repeated addition, specifically plus 2, then I would say that this is an arithmetic sequence. Like I mentioned, it could also be subtraction. So if you see a pattern of repeated subtraction, that's also an arithmetic sequence. Here, I'm subtracting 4 each time. Therefore, I would identify this as an arithmetic sequence. So some questions will just ask you that. Is it arithmetic or is it geometric? On these problems, it's very common for students to say something like, oh, it's going up by 2. But because we're talking about different sequence types, you need to specify the operation. So don't just say it's going up 2 or down 4. You need to say the pattern. In addition to the number, you need to say the operation. So you would say addition of 2 or plus 2 each time. That helps us identify it as an arithmetic sequence. Geometric sequences, on the other hand, which is what we're going to lean into in Unit 6 as a review, geometric sequences are patterns of repeated multiplication or division. So if I see a repeated pattern of multiplication or division, then I can identify the sequence as being geometric. While arithmetic sequences model a linear function, geometric sequences will model exponential functions. And the simplest parent function of a geometric sequence is y equals a times b to the x. So if I see a repeated pattern of multiplication, which would be the b here in this case, then I can identify it as a geometric sequence. So for instance, here if I have 2, 4, 8, 16, 32, etc., here my pattern is multiplying by 2, therefore I could identify this as a geometric sequence. Now, I just mentioned a second ago that you don't want to just say up 2 because if you look at example 1 and example 3 here, both of those are going quote-unquote up by 2, but one is addition, one is multiplication. So you do need to specify what the operation is so we can identify what type of sequence it is. And then similarly with geometric sequences, we could also have a repeated pattern of division. So let's say I have 100, 10, 1, 1/10, etc. Sometimes you'll be given more than 2 terms. Sometimes you'll be given 3 terms, 4 terms, 5 terms, but pattern is the same. So we're looking for what the pattern is here. Each time I'm dividing by 10, and therefore because I'm dividing by the same amount each time, I would identify this as a geometric sequence. That's the majority of your assignment for 6.1. All of these examples I'm using integer values for my either rate of change or my ratio. So in number 1, I'm adding by 2, and number 4, I'm dividing by 10. The ratio doesn't have to be a whole number. It can be a different value. Also, most students are okay with identifying the pattern, but if you're ever unsure of what the pattern is supposed to be, specifically with geometric sequences, what you can do is just divide any two sequential numbers, and that'll give you the ratio. Some questions might ask you for the ratio, some questions might ask you for the nth term in a sequence. So, for instance, let's say I had 4, 16, 64, and I ask you for the fifth term in the sequence. So the terms are each number that comes in the sequence. So right here at number 5, we have 3 terms. We have 4, 16, and 64. If I'm not sure what the pattern is here, I can always divide the two terms. So if I take 16 and divide it by 4, that gives me 4, which is my ratio here. That's what I'm multiplying each time. Some questions will ask you for a specific term. So if I'm asking you for the fifth term, I want to find the fifth number in the sequence. So I would then need to do 64 times 4, and then times 4 again, because I'm asked for the fifth term. If I multiply 64 times 4, that gives me 256. And if I multiply that one more time, that gives me 1,024. So the answer here, if it's asking specifically for the fifth term, would be 1,024. On a multiple choice test, it might give you 256 as a possible answer, but you need to pay attention for what the directions are asking you for. So it's possible that you might be asked for the nth term, for instance, like I said, the fifth term. You could also be asked to identify the next 3 terms or the next 5 terms in the sequence. So repeating number 3 here, if I have 2, 4, 8, 16, 32, I might ask you for the next 3 terms in the sequence. If that's what you're being asked, then you need to have 3 numbers that come next. As we saw in number 3, this is a pattern of repeated multiplication. So the next 3 terms of the sequence would be 32 times 2, times 2, times 2, and that would be my answer because those are the next 3 terms. So pay attention to what the question is asking you to do. As I mentioned, it's possible that you get a value for either a ratio or a rate of change that's not a whole number, a decimal or a fraction. So let's say I have something like 10, 15, 22.5, etc. And I ask you for the ratio. These are a little bit harder to see when the value is not an integer. As we did in number 5, you can always figure out what the ratio is by dividing any two numbers. So let's say 15 divided by 10, any two sequential numbers. And that gives me either 3/2 if I like working with fractions, or as a decimal, that would be 1.5. And then from there, if I wanted the next term in the sequence or the next 3 terms in the sequence, I would just take that 1.5 and continue to multiply. That's it for this section. If you have any questions, please reach out to me during office hours. Otherwise, have a good day, and I will talk to you soon. Bye.